Hello dear learners, myself Prabha Biju, Assistant Professor at the Department of Computer Applications in the Bhopal School of Social Sciences. The topic for this module is Process Management. Process management is one of the most important functions of an operating system. In this module, you will learn process concepts, definition of process, difference between a program and a process state, its life cycle, process states and state transitions, process control block, that is also known as PCB, and we will also learn operations on a process. You know that computer performs concurrently. For example, compiling a program, sending a file to a printer, rendering a web page, playing music and receiving email. It performs all these tasks concurrently. Processes enable systems to perform and track simultaneous activities. Processes transition between process states. There is transition that takes place between two states of a process. Operating system perform operations on processes such as creating a process, destroying a process, or we can say terminating a process, suspending, resuming and waking of a process. Now let us see what are the goals of operating system in process. So the very first goal of operating system we can see here is that interleave the execution of existing process to maximize processor utilization. So as we know that the aim of operating system is to maximize the CPU utilization. So it interleaves the execution of the processes. Secondly, it provides reasonable response times. It allocates, operating system must allocate resources to processes, and it also must protect the resources of each processes. And it also supports inter-process communication. It allows process to communicate with each other and share the resources, and also it supports synchronization and user creation of a processes. Now let us see how these goals are achieved. The operating system uses programs for scheduling and dispatching processes for execution by the processor. It implements a safe and fair policy for resource allocation to processes. As we discussed earlier, that it allocates resources to the competing process, and it also uses some scheduling policy for allocating processor to those process. It responds to requests by user program. Operating system responds to the user program, and it also constructs and maintains tables for each process managed by the operating system. Now, what are the fundamental services that are provided by the operating system to the process? The very first service is creating processes. Operating system create process, that means it brings the process from the secondary memory to the primary memory. Destroying processes, or we can say terminating processes, if process successfully executes and that process is terminated. Next is suspending processes. Suspending processes are those processes which are suspended from the processor and they are kept in the suspended mode. Resuming processes, the processes which are suspended, they are resumed again. Changing a processor's priority. Operating system also changes the priority of the process which are in a queue in the ready state. Operating system blocks the processes which awaits some events that needs to be occurred. It wakes up the processes, dispatching of processes which are there in the ready queue, and it is sent for execution in the processor. It also allows inter-process communication between or amongst the processes which are competing for the processor. So what is the definition of a process? A process is a part of program that is in execution. A process has its own address space that consists of text region, data region and stack region. Text region that stores the code that the processor executes. Data region stores variables and dynamically allocated memory. Stack region has instructions and local variable for active procedure calls. So, before we further understand more concepts of process, let us differentiate between program and process. As we know that program consists of set of instructions designed to complete a specific task. Usually programs are written in computer programming language like C, C++ or Java. And a process is an instance or a part of program in execution. Second difference is that program is a passive entity or an object as it resides in the secondary memory. So, program always kept in the secondary memory, whereas process is an active entity or an object as it is created during execution and loaded into the memory. So, whenever a part of a program needs execution, it is brought from the secondary memory into the primary memory. Third difference is program exists at a single place and continues to exist until it is deleted. Until and unless we delete program from the secondary memory, it exists in the memory. Whereas process exists for a limited span of time as it gets terminated after the completion of task. As soon as the execution is completed, it is terminated from the primary memory. That is why we say that process exists for limited span of time. Program is static entity or object that exists in a file. Process is a dynamic entity or object that is a program in execution. Program does not have any resource requirement. It only requires memory space for storing the instruction. It doesn't require any other resources. Process has a high resource requirement because it requires resources during execution. It needs resources like CPU, memory address, I/O during its lifetime. The last difference we see here is program does not have any control block, whereas process has its own control block which is known as PCB or process control block. As soon as a process is created, automatically process control block is also created by the operating system. Now let us understand the life cycle of a process. Each and every process has its own life cycle. It moves from one state to the other state. A process moves through a series of discrete process states like running state, ready state, block states. Running state, the process is executing on a processor. It is called as a running state when it is there in the CPU or in the processor for execution. It moves in the ready state when it has all the other resources other than the processor. Blocked state, the process is waiting for some event to happen before it can proceed. Those states are known as blocked state. The operating system maintains ready list and blocked list to restore references to processes not running. Process states and state transition. As I told you earlier, that each and every process keeps changing its state. So, the process states acts of assigning a processor to the first process on the ready list is called dispatching. So, this dispatching is done by the dispatcher, which is a program that takes the process from the ready queue and assigns the CPU. The OS may use an interval timer to allow a process to run for a specific time interval or quantum. Sometimes, according to the policy, the operating system or the CPU executes the process for some specific time interval or quantum. Cooperative multitasking lets each process run to completion. State transitions, there are 4 possible state transitions. When a process is dispatched, it transitions from ready to running. When a process is dispatched from the ready queue to the CPU, a transition is happening. Next transition is when the quantum expires, it transitions from running to ready. When the time expires, then the CPU gives back the process into the ready queue. When a process blocks, it transitions from running to blocked. When operating system blocks a process, it moves from the CPU to the block state. So, running to blocked. Next is when the event occurs, it transitions from blocked to ready. The processes which require some events that has to be occurred, that is brought from the CPU to the blocked state, and then it goes back from blocked to ready state. So, these are the 4 possible state transitions. Now, let us understand with the help of this diagram process state and state transition. You see here 3 states. First state is ready, running and blocked. Ready state is the state where all the process are waiting for CPU for the execution or running. So, CPU or dispatcher dispatches the process to the CPU that is in the running state. And when the time is out, it is back from the running state to the ready state. And from the running state, some of the process are blocked. So, it goes into the blocked state. When process requires some I/O synchronization or it waits for some event to be occurred, that is taken away from the running state to the blocked state. And when that synchronization is done, that is again brought back from the blocked state to the ready state. Now, let us once again understand by a diagram that is given by the Professor Milankovic in his book called Operating System, Its Concepts and Design. Milinkovic has explained the process transition states in 4 states. So, let me make 4 circles here. He has named the first state as dormant. Dormant means sleep or which is not active. Second state is ready. Third state is execution. Fourth state is either we can say suspended or blocked. So, dormant state means when the programs are stored in secondary memory. It is sleeping, it is not active. So, once when operating system creates the process that are in the ready state. So, when a process is created, they move into the ready state. From the ready state, operating system applies some scheduling policy and schedules the process to the CPU for execution. So, the next state is execution. And so, when a process is successfully executed or processed, it is terminated from the execution state back to dormant state. So, it is terminated. So, back from the CPU to the dormant state which is residing in the secondary memory. So, I hope this part is very clear. From dormant state to ready state, when it is created, operating system provides all the resources that is demanded by the competing process and it is scheduled the CPU, it gets executed and it is terminated, which goes back to the secondary memory. Now, let us come to this part. Sometimes operating system preempts the processes and moves back to the ready state, like when operating system uses policies of time quantum or priority. So, when time quantum is exceeded, it is preempted back to the ready state. So, operating system preempts from the CPU back to the ready state, from the execution state to the ready state. Sometimes during execution, process requires some I/O synchronization. It requires some input-output device or it awaits for some events to be happen. Then it is taken back to the suspended or blocked state. So, there can be 2 reasons: awaits event or I/O synchronization. So, those processes comes in suspended state or ready state. When input-output synchronization happens or event happens, then it is moved back to the ready state. So, these are the 4 states of processes: dormant, ready, execution, suspended, or we can also say blocked state. I hope now it is very clear about the process state transition. As I have explained you that whenever a process is created, its corresponding PCBs or process control block, or which is also known as JCB, that is job control block, is also created by the operating system. So, in PCBs, it describes each processes. So, in this diagram, you can see that it has process table which has process ID and the PCB. So, each PCB has its program ID or process ID. So, you see here there can be n number of program ID as we keep n number of PCBs. So, what is the content or description given here in the process control block? That is related to the process, like program counter, registers, state of a process, priority of a process, address space, then detail about the parent process, children process, and other details are available, that is referred by the operating system while execution of a process. Now, let us first see the operations on processes. A process may spawn a new process. So, the creating process is called parent process. The created process is called child process. The parent process is a process that creates a child process. Exactly one parent process creates a child process. When a parent process is destroyed, operating system typically respond in one of two ways, that is destroy or terminate all child process of that parent, or allow child processes to proceed independently of their parents. So, dear learners, in this module we have seen the process concept, we have seen the definition of process, we have seen the difference between program and process. Also, I have explained you about life cycles of a process. We have seen state transition. We have learnt about process control block and operations on a process. I hope the topic for this module is very clear to you.